In this video, we're going to be looking at two things, and the first one is what we call rationalization. Now, when we talk about rationalization, rationalization is the process of dividing a surd. This is the process of dividing a surd. So when you try to divide a surd, what you're trying to do is what we refer to as rationalization of a surd. Now, there are two cases of rationalization. There are two cases of rationalization. We have what we call the simple case, and we have what we call the complex case. Now, let's start with the simple case. If you are told to find 6 over root 2, now you want to divide this. Now, having root as the denominator is not right. Just like the way you cannot say 4 over minus 2 in math. Rather, you will say minus 4 over 2, or you write 4 over 2 and put the minus in the middle. So the process of trying to eliminate the square root at the denominator is the rationalization itself. So in this simple case, all you do is to multiply the given surd by the denominator. The denominator is root 2, so I will just multiply the 6 over root 2 by root 2 over root 2, and that will give me 6 root 2 divided by root 4. And what is the square root of 4? The square root of 4 is 2. And you can do 2 here 1, 2 here 3 to make the result to be 3 root 2. This is the process of trying to divide a simple surd. Process of trying to divide a simple surd. Okay, so what happens if I have a question like this? 2 root 3 over root 5. The same process. That gives you 2 root 3 over root 5 times root 5 over root 5. 2 root 3 times root 5 will give us 2 root 15. Root 5 times root 5 will give us root 25. And that gives us 2 root 15 over 5. Please note, you can't say 5 here 1, 5 here 3, because the 15 is in the roots, but the 5 is not in the roots. So this is how you run the simple case when performing the operation of rationalization. Now we move to the complex case. Now, before doing this, we need to quickly recap on something we learned before rationalization that we call conjugates. And we said 2 plus root 3, while the conjugates would definitely be 2 minus root 3. That's really important for you to know, because don't forget that the product of a surd and its conjugates gives a rational number. And you're going to see the process really quick, simple, and very direct. Now let us examine this question. 3 plus root 2 divided by 3 minus root 2. So what I'm going to do is, this is the denominator of the surd. I will conjugate this denominator. So that means I'm going to have 3 plus root 2, still the original surd, divided by 3 minus root 2 times, what is the conjugate of 3 minus root 2? The conjugate of 3 minus root 2, which is denominator, is 3 plus root 2 over 3 plus root 2. Technically, what you have just done now is the same as the original question. Because if you want to do normal math, you can just say 3 root 2 cancel 3 root 2 and you'll be left with 3, but you can't do that. So the process of doing this, you will look at the denominator now. The denominator are conjugates of each other. So by the time you multiply it, you will no longer have a surd there. So let us see what that will produce for us. Now, we've learned how to expand. So 3 times 3, which is a 9. 3 times root 2, which is 3 root 2. Root 2 times 3, which is 3 root 2. Root 2 times root 2, which is root 4. Divided by 3 times 3, which is 9. 3 times root 2, which is 3 root 2. Root 2 times 3 minus 3 root 2 minus root 2 times root 2, and that's minus root 4. 3 root 2 will cancel this out and we'll be left with what? 9 plus 6 root 2 plus 2 divided by 9 minus 2. And this will give me 11 plus 6 root 2 divided by 7. You see that now? You have successfully eliminated roots from the denominator. But the only way to do that is to ensure that you multiply by the conjugates. And this is also the concept of rationalization. Let's take one or two more questions on this complex case to solidify our understanding effectively. If I have a question like 3 root 2 plus 2 divided by 1 minus root 2. So I already know the denominator to be 1 minus root 2, and the conjugate of that is 1 plus root 2. So we commence the expansion. 3 root 2 times 1 will give us 3 root 2. 3 root 2 times root 2 will give us 3 root 4. 2 times 1 will give us 2. 2 times root 2 will give us 2 root 2. 1 times 1 will give us 1. 1 times root 2 will give us root 2. Minus root 2 times 1 will give us minus root 2. Minus root 2 times root 2 will give us minus root 4. Root 2 will cancel out minus root 2, and we will now have 3 root 2 plus 3 root 4 is going to give us 6. Why? Because root 4 is 2. 3 times 2 will now be that 6 plus 2 root 2 divided by 1 minus 2, which becomes 6 plus 2 is 8. 3 root 2 plus 2 root 2 is 5 root 2 divided by negative 1, which is the same thing as minus 8 minus 5 root 2. Now, I'd like you to try this. You can pause the video to try this. After you are done, you can play again to see the solution. So this would give us 3 root 5 minus root 2 divided by 3 root 5 minus root 2. So we expand. 5 times 3 root 5 will give us 15 root 5. 5 times root 2 will give us minus 5 root 2. Minus 2 root 10 times 3 root 5 will give us minus 6 root 50. Minus 2 root 10 times minus root 2 will give us minus 2 root 20. 3 root 5 times 3 root 5 will give us 9 root 25. 3 root 5 times minus root 2 will give us minus 3 root 10. Root 2 times 3 root 5 will give us plus 3 root 10. Root 2 times minus root 2 will give us minus root 4. Now, we will see that root 50 is reducible. Root 20 is also reducible. So let's quickly check that out. Root 50 is the same thing as 5 root 2. Root 20 is the same thing as 2 root 5. So that will give us 15 root 5. Let's not forget that minus 3 root 10 will cancel 3 root 10. So 15 root 5 minus 5 root 2. Since we already know our root 50 to be 5 root 2, so 6 times that 5 root 2 will now become minus 30 root 2. We already know our root 20 to be 2 root 5. Multiplying that by 2 will give us minus 4 root 5. Divided by root 25 is 5. 9 times 5 is 45. Root 4 is 2. So this will produce 15 root 5 minus 4 root 5 will give us 11 root 5. Minus 5 root 2 minus 30 root 2 will give us minus 35 root 2 divided by 43. And that gives us the result. This is the concept of rationalization. Let's not forget there are two categories. There is the simple case and there is the complex case. I hope this video helps to you in understanding the concept of rationalization of surds. Thank you for listening.